Our fascination with the weather is as old as humanity itself. From the earliest days, humans have looked to the skies, wondering and hoping to harness its power. From ancient rain dances to modern meteorology, we've always sought to understand and influence the skies above. These efforts reflect our enduring desire to predict and perhaps even control the weather. Today that ambition has taken on a new form: geoengineering. This cutting-edge field represents the pinnacle of our quest to manage the climate. This field of science explores deliberate, large-scale interventions in the Earth's climate system, aiming to counteract the effects of climate change. Techniques range from carbon capture to solar radiation management. It's a concept both thrilling and daunting, promising solutions to some of our most pressing environmental challenges, while raising profound ethical and practical questions. The implications of such power are vast and complex. The idea of controlling the weather, once relegated to the realm of science fiction, is now a topic of serious scientific inquiry. What was once fantasy is becoming a potential reality. Could we one day summon rain to drought-stricken lands, or deflect hurricanes away from populated coastlines? The possibilities are both exciting and unnerving. The potential benefits are immense, but so are the risks. The stakes are incredibly high, and the margin for error is slim. As we delve deeper into the science of geoengineering, we must proceed with caution, guided by a deep understanding of both the potential benefits and the unintended consequences of tampering with Earth's delicate climate balance. The future of our planet may depend on it. Among the various geoengineering techniques being explored, cloud seeding is one of the most well-known. This method involves introducing substances like silver iodide into clouds to stimulate rainfall. The silver iodide particles act as condensation nuclei, providing surfaces for water vapor to condense around, thus promoting the formation of raindrops. While cloud seeding has been practiced for decades, its effectiveness remains a subject of debate. Some studies suggest that cloud seeding can increase precipitation by 10 to 30% under favorable conditions. However, accurately measuring the effectiveness of cloud seeding is challenging, as natural variations in weather patterns can make it difficult to isolate the impact of the intervention. Furthermore, cloud seeding can only induce rainfall if there's sufficient moisture already present in the atmosphere. It's not a solution for regions experiencing severe drought where atmospheric moisture is scarce. The growing interest in weather modification technologies is reflected in the market's rapid expansion. In 2020, the global weather modification market was valued at approximately $1 billion, and it's projected to grow by 5% annually. This growth is driven by increasing demand for water resources, particularly in arid and semi-arid regions, facing water scarcity due to climate change and population growth. However, the ethical implications of weather modification are substantial. One concern is the potential for one region to benefit from increased rainfall at the expense of another, leading to accusations of stealing rain. Additionally, the long-term ecological impacts of introducing foreign substances into the atmosphere are not fully understood. We must tread carefully, weighing the potential benefits against the risks of unintended consequences. While the idea of controlling the weather holds immense appeal, the reality is far more complex and daunting than it initially appears. The Earth's climate system is incredibly intricate, with countless variables interacting in ways we don't fully comprehend. Scientists have spent decades studying these interactions, yet we are still far from understanding the full picture. Achieving precise control over something as chaotic as the weather is a monumental challenge. Atmospheric scientists caution that refining geoengineering methods to a point where they can be deployed safely and effectively could take decades of research and development. Moreover, even if we could achieve a high degree of precision in our interventions, there's always the risk of unintended consequences. Modifying one aspect of the climate system could have unforeseen ripple effects on other parts of the system. For instance, increasing rainfall in one region might inadvertently alter wind patterns, leading to drought in another. The interconnectedness of Earth's climate system means that any intervention, no matter how well-intentioned, has the potential to backfire. This complexity underscores the importance of continued research and cautious experimentation. Only through a deep and nuanced understanding of our climate can we hope to responsibly manage and perhaps one day influence it. Until then, we must tread carefully, respecting the delicate balance of our planet's climate system. The stakes are high, and the potential for unintended consequences is ever present. The future of weather control lies in our ability to learn, adapt, and respect the natural systems that sustain life on Earth. Section 5. The need for international cooperation. Given the global nature of climate change and the potential for transboundary impacts from geoengineering, international cooperation is essential. Unilateral action by one nation could have unintended consequences for others, leading to tensions and even conflict. A coordinated global effort is needed to establish clear guidelines and regulations for geoengineering research and deployment. This international framework should address several critical issues, including who has the authority to conduct geoengineering experiments and deploy these technologies at scale? How will the risks and benefits of geoengineering be assessed and distributed? And how can we ensure that geoengineering research and deployment are conducted transparently and accountably, with input from all stakeholders? Section 6. Unintended consequences, a cause for concern. The potential for unintended consequences is perhaps the most significant challenge associated with geoengineering. Our understanding of the climate system is still evolving, and it's impossible to predict with certainty how large-scale interventions might impact the planet. Some potential risks include disrupting regional weather patterns, altering ocean currents, damaging the ozone layer, and even triggering unforeseen feedback loops that could exacerbate climate change. For instance, injecting sulfate aerosols into the stratosphere to reflect sunlight and cool the planet could also disrupt precipitation patterns, potentially leading to droughts in some regions. Additionally, these aerosols could accelerate the depletion of the ozone layer, which protects us from harmful ultraviolet radiation. These risks highlight the need for extensive research and modeling before deploying any geoengineering technology at scale. Section 7. Ethical frameworks for responsible geoengineering. Given the profound ethical implications of intentionally manipulating the Earth's climate system, robust ethical frameworks are essential for guiding geoengineering research and deployment. These frameworks are not just theoretical constructs but practical guides that can help navigate the complex moral landscape of geoengineering. These frameworks should address questions such as, is it ethically permissible to intentionally alter the planet's climate system, even if it's done with the intention of mitigating the harms of climate change? What are the potential long-term consequences of such actions? Who has the right to make decisions about geoengineering deployment, especially when those decisions could have global consequences? Should these decisions be made by a select few, or should there be a more democratic process involving a wider range of stakeholders? One proposed ethical framework emphasizes the principles of precaution, justice, and transparency. These principles are designed to ensure that geoengineering practices are conducted responsibly and ethically. The precautionary principle suggests that in the face of uncertainty about the potential harms of geoengineering, we should err on the side of caution and avoid deploying these technologies until we have a better understanding of their risks. This principle is crucial in preventing unintended negative consequences. The justice principle highlights the need to ensure that the benefits and burdens of geoengineering are distributed equitably, both within and between generations. This means considering the impacts on future generations and ensuring that no group bears an unfair share of the risks or costs. And the transparency principle calls for open and inclusive decision-making processes that involve all stakeholders, including those who might be affected by geoengineering deployment. This ensures that the voices of marginalized communities are heard and considered in the decision-making process. Section 8. Balancing innovation with environmental stewardship. As we stand on the precipice of a new era in our relationship with the planet, we must proceed with both ambition and humility. Geoengineering offers a tantalizing glimpse into a future where we might possess the tools to directly counteract the effects of climate change. However, this power must be wielded with great care and responsibility. Our first and foremost priority should always be to reduce our reliance on fossil fuels and transition towards a more sustainable future. Geoengineering, if pursued, should be seen as a complementary strategy, not a substitute for reducing greenhouse gas emissions. We must invest in robust research programs to better understand the potential risks and benefits of geoengineering, develop international governance mechanisms to ensure its responsible use, and engage in open and inclusive public dialogues about the ethical implications of these powerful technologies. Section 9. Conclusion. A future of possibilities and challenges. The quest to control the weather is a testament to human ingenuity and our enduring desire to shape the world around us. Geoengineering, while still in its infancy, holds both promise and peril. It offers a potential lifeline in the face of accelerating climate change, but also presents profound ethical and practical challenges. As we venture further into this uncharted territory, we must proceed with caution, guided by a deep respect for the planet and a commitment to safeguarding the well-being of all living things, now and in the future. The choices we make today will determine the course of our planet's future. Let us choose wisely, ensuring that our pursuit of technological solutions aligns with our responsibility to protect the delicate balance of nature and create a just and sustainable world for all.